There's a clay tablet sitting in a museum right now, a fragment of baked earth so old that the civilization that made it collapsed before Rome was even a village. It is covered in wedge-shaped marks pressed into its surface by a reed stylus, fired into permanence by a kiln, and then buried beneath the ruins of a city that no one remembered for 4,000 years. When archaeologists eventually pulled it from the ground in the 19th century, they thought they understood what it was. They catalogued it, translated it, shelved it. It seemed on the surface to be nothing more than another record of the Sumerian cosmos, another priestly text mapping the stars, naming the gods, describing the heavens in the poetic language of a civilization that humanity had long since left behind. But something in that text refused to be settled. The more scholars returned to it, the more a certain unease grew, not because the tablet was wrong, not because it contradicted known history, but because, in several places, it seemed to know things it had no right to know. It described celestial mechanics with a precision that should not have been possible without instruments that were not invented until millennia later. It spoke of objects in the sky using numbers and cycles that, when checked against modern astronomical data, aligned with an accuracy that is deeply uncomfortable to explain. And buried within its astronomical framework, woven into the structure of its star catalogs and divine chronologies, there appeared to be something that some researchers have begun to interpret as a calendar, not a calendar of seasons or harvests or festivals, but a calendar pointing toward a specific kind of event. An event the Sumerians described not as something that had happened, but as something that would happen. Something involving a signal, something involving contact, something involving beings who left, and who were, according to the text, scheduled to return. This is not fringe speculation. This is what happens when you take Sumerian cuneiform seriously as a body of astronomical knowledge and follow the numbers wherever they lead. The Sumerians emerged in the river valleys of what is now southern Iraq, somewhere around 3500 BCE. They were, by any reasonable measure, the first civilization, the first culture to develop writing, to build cities, to establish law, to create literature, to systematically record and transmit knowledge across generations. Before Egypt built its first pyramid, the Sumerians had already been writing for centuries. They left behind hundreds of thousands of clay tablets covering every imaginable subject: legal contracts, medical diagnoses, agricultural records, hymns to their gods, mathematical problems, philosophical reflections, and, above all, an enormous body of astronomical observation, so detailed and so precise that modern astronomers still study it today. And this is where things begin to get interesting. The Sumerians were not casual stargazers. They were systematic, methodical, almost obsessive observers of the sky. Their astronomical records spanned generations. Scribes copied earlier observations onto new tablets and added their own, creating chains of data that stretched back centuries before the moment of recording. One of the most important of these astronomical documents, a two-tablet compendium known today as the Mul-Apin, is considered the earliest surviving comprehensive astronomical text in human history. It was compiled around 1000 BCE in its canonical form, but it draws on observations and traditions that reach back to at least 2000 BCE and possibly earlier. The Mul-Apin catalogues 71 stars and constellations, describes their rising and setting times with mathematical precision, outlines the movements of the 5 known planets, establishes the structure of the Babylonian calendar, and organizes the entire sky into 3 celestial zones: the path of Enlil in the north, the path of Anu along the equator, and the path of Ea in the south. A clay tablet translated in 2015 demonstrated that Babylonian astronomers, the direct successors of the Sumerians, had made extremely accurate mathematical calculations for the orbit of Jupiter a full 1400 years before European astronomers did the same thing. These were not lucky guesses. These were the products of a sophisticated mathematical framework applied consistently over centuries, producing results that hold up under modern scrutiny. The Sumerians, and the civilization they seeded, were doing real science. Now hold that thought, because here is where the story takes a turn. Alongside the technical astronomical records, alongside the star catalogs and the planetary tables and the eclipse predictions, the Sumerians recorded something else. They recorded the stories of the Anunnaki. In the cuneiform texts, the Anunnaki are described as the great heavenly beings, the sons of Anu, the supreme sky god. They descended from the heavens. They walked among humans. They taught civilization. They gave knowledge. They established kingship. And then, according to the texts, they departed. The word Anunnaki itself, derived from the Sumerian Anunna combined with the syllable for earth, carries within it the fundamental tension of these beings. They were of the sky, and they came to the earth, and the distance between those two things defined everything about them. Zecharia Sitchin spent decades arguing that the Anunnaki were not merely mythological constructs, but literal extraterrestrial beings, Specifically, visitors from a planet he identified as Nibiru, a large body he claimed the Sumerians described as following a vast elliptical orbit that brought it near Earth only once every 3,600 years. Sitchin's theories attracted enormous popular attention and, in roughly equal measure, fierce rejection from mainstream academics, who pointed out significant translation errors in his interpretations and argued that his reading of the tablets were creative reinterpretations rather than accurate translations. The scholarly consensus is firm. Sitchin's specific claims about Nibiru and its inhabitants are not supported by the actual Sumerian texts, as they are currently understood. But here is what mainstream scholarship cannot dismiss as easily. The astronomical framework embedded in the Sumerian texts is genuinely extraordinary. And when you look at that framework, not through the lens of mythology, but through the lens of information theory, when you ask not what the Sumerians believed, but what they recorded and how accurately they recorded it, the picture becomes significantly more complicated. The Mu-Ezel-Apin does something unusual. It does not merely describe the sky as it appears from Earth. It describes relationships between celestial objects in ways that require a deep understanding of the underlying mechanics of the solar system. It describes the paths of planets not just as tracks across the night sky, but as predictable, cyclical phenomena governed by consistent mathematical rules. It describes the precession of the equinoxes, the slow wobble of Earth's axis that shifts the position of the stars over a cycle of approximately 26,000 years, with enough accuracy that modern researchers have been able to use the positional data in the MUL-Apin to date some of its observations to as early as 2300 BCE and possibly earlier. Precession is an extremely subtle phenomenon. It was not described formally in the Western astronomical tradition until Hipparchus, a Greek astronomer, around 130 BCE. Yet the Sumerian records show awareness of it centuries, possibly millennia before that. Where did this knowledge come from? The straightforward answer is that it was accumulated through patient, systematic observation over very long periods of time. That is the answer mainstream astronomy offers, and it is a reasonable one. Human beings are capable of extraordinary things when they commit to careful observation over generations. The long baseline of Sumerian skywatching could, in principle, have produced the precession data without any external input. But there is another question that this explanation leaves unaddressed, and it is the question that brings us back to the opening premise of the story. The Sumerian texts do not describe the cosmos as static. They describe it as cyclical. Everything in the Sumerian cosmological framework moves in cycles. The seasons, the planets, the stars, the fates of civilizations, the activities of the gods themselves. And crucially, the cycles do not merely repeat in the background as neutral astronomical fact. In the Sumerian worldview, the cycles mark appointments. They mark the times when certain things are meant to happen, when certain beings are meant to appear, when the connection between the heavens and the earth is meant to reopen. This idea, that specific astronomical configurations correspond to specific events in the relationship between humanity and the sky, is embedded throughout the cuneiform record. It is in the astrological omen texts, where particular planetary conjunctions are associated with particular outcomes. It is in the kingship narratives, where the descent of divine authority from heaven corresponds to specific celestial moments. It is in the great mythological texts, where the activities of the Anunnaki, their arrival, their withdrawal, their periods of active involvement with humanity, all follow a temporal structure linked to the heavens. Now, here is where something genuinely strange surfaces. When researchers attempt to reconstruct the chronological framework implied by the Sumerian divine cycle, using the astronomical data in the tablets to project the positions of the stars and planets described as significant, they arrive at a sequence of dates. Some of these dates correspond to known historical events. The destruction of cities, the rise of new dynasties, the great upheavals of ancient history all seem to cluster around the transition points in the Sumerian cosmic cycle. And at the far end of that projection, beyond all of the historical markers, the cycle points forward to a date that has not yet occurred in ancient history because it lies in our own time. The specific number embedded in the Sumerian texts that has attracted the most attention in this context is the great cycle of the precession of the equinoxes, 25,920 years, the time it takes Earth's axis to complete one full wobble. The Sumerians appear to have known this number. They encoded it in their mathematical systems, in their mythological chronologies, in the lifespans assigned to their antediluvian kings, and they divided it into smaller periods of cosmological significance, each one associated with different phases of the relationship between Earth and the divine sky beings who, according to their texts, periodically intervened in human affairs. What makes this framework so unsettling to dismiss is not any single calculation, but the cumulative precision with which the Sumerians seem to handle numbers of this magnitude. These were people using a base 60 mathematical system, the sexagesimal system that we still use today when we divide an hour into 60 minutes and a minute into 60 seconds. Their mathematics was not primitive. It was different from our own in its notation, but it was entirely capable of handling very large numbers with great precision. And when you apply that system to the cosmic chronologies and the tablets, the internal consistency of the numbers is remarkable. The question is not whether the Sumerians were doing mathematics. Clearly they were, and doing it well. The question is where they got the initial data from, the long baseline of observations that would have been required to identify and quantify the precessional cycle, because to measure precession accurately from scratch, you need observations spanning many centuries, if not longer. You need to compare star positions across generations with a consistency that most ancient cultures simply did not maintain. Yet the Sumerians appear to have had this data. They appear to have had it at the very beginning of their civilization, rather than accumulating it slowly over time, as you would expect from a purely observational tradition. This is the anomaly that serious researchers keep returning to. Not the mythology around the Anunnaki, not the popular theories about ancient aliens and genetic engineering and gold mining operations, but the baseline question of how a civilization that had been writing for perhaps a few centuries came into possession of astronomical knowledge that should have required millennia to accumulate. One interpretation, the conservative one, is that the knowledge was inherited from an even older, now vanished culture whose astronomical traditions the Sumerians absorbed and preserved without attribution. The world before Sumer is largely a mystery. The period known as the Younger Dryas, which ended around 9700 BCE, saw dramatic environmental changes that would have disrupted or destroyed any complex civilization that existed before it. If such a civilization had existed and had accumulated a long baseline of astronomical observation, the Sumerians, who emerged in the aftermath of that disruption, might genuinely be transmitters of knowledge whose original sources are lost to us. Another interpretation is more radical. It is the one that the popular imagination has seized on and that professional scholarship has been reluctant to engage with seriously, partly because of the way it has been packaged in pseudoscience, and partly because its implications are too large to process without first confronting the entire framework of human history. That interpretation is that the astronomical knowledge in the Sumerian texts did not come from within human civilization at all, that it was transmitted from outside, from the beings the Sumerians called the Anunnaki, from whatever those beings actually were. If that interpretation is correct, and it is important to say clearly that it remains deeply contested and unproven, then the Sumerian texts are not just historical documents. They are a record of contact, and the chronological framework embedded in those texts is not just a mythological calendar. It is a schedule. It describes when the contact happened, how it was maintained when it ended, and when, according to the logic of the same astronomical cycles, the texts use for everything else. It is meant to resume. This is the layer of the Sumerian record that the clickbait headlines have latched onto, but that genuine researchers have been reluctant to discuss in precise terms, because the terms require acknowledging a framework of interpretation that mainstream scholarship rejects. But the numbers are there, the cycles are there, and they point towards something. The modern search for extraterrestrial intelligence has, for decades, been conducted as if contact would come from outside, from a signal arriving from a distant star, picked up by a radio telescope in a remote desert, analyzed by algorithms looking for patterns too structured to be natural. The search has always been oriented outward and forward. We are waiting for something to arrive from out there at some unknown point in the future. This assumption underlies all of SETI's methodology. It underlies the protocols that a team of scientists updated just weeks ago in preparation for a potential detection event, the new 2026 Declaration, which establishes strict guidelines for how any credible signal should be verified, disclosed, and responded to. But what if the signal has already been described? What if the first contact event was not something we are waiting for, but something that was recorded, encoded in astronomical cycles, and preserved across 5,000 years of cuneiform text, waiting for us to develop the tools sophisticated enough to read it properly? The answer to that question depends on how you read the texts, and how you read the texts depends on what assumptions you bring to the reading. If you assume the Anunnaki were mythological, gods invented to explain the order of the cosmos, then the tablets are religious literature. If you assume they were metaphors, the Sumerian way of personalizing natural forces, then the tablets are poetic cosmology. But if you ask the harder question, what if the Sumerians were writing about something they had actually experienced and encoding it in the most durable and accurate system they had available, which was astronomical time? Then the tablets become something else entirely. They become a message. Not a message sent to us deliberately, perhaps, but a message nonetheless. A record left by people who knew something unusual had happened, who wanted to make sure that record survived, and who wrapped it in the most precise and enduring medium they had. The cycles of the stars, whose accuracy could be verified by any sufficiently advanced civilization that came after them. Today, artificial intelligence is beginning to transform how we read these texts. Researchers are applying machine learning to the vast corpus of undeciphered or partially deciphered cuneiform tablets still sitting in museum vaults around the world. What used to take a cuneiformist decades of painstaking work, piecing together broken fragments, cross-referencing sign variations across different scribal traditions, reconstructing damaged passages, can now be approached with tools that process thousands of tablets simultaneously, identifying patterns and connections that no single human scholar could track. The implications of this for Sumerian studies are enormous. We are, right now, in the early stages of a mass decipherment project that may eventually give us access to the full content of a textual tradition that is still only partially understood. What that project will reveal is genuinely unknown. It may produce more trade records and administrative lists, the mundane paperwork of an ancient economy. It may produce new versions of already known mythological texts, or it may produce something that no one expected. Passages in which the astronomical framework and the narrative of the Anunnaki and the cycle of cosmic time converge on something specific enough to constitute a date. If that happens, if an AI-assisted translation of a previously unread or misread Sumerian tablet produces coordinates in astronomical time that correspond to a calculable moment in our own era, the world will face a question that no protocol, no United Nations committee, no international framework currently exists to answer. Because the question will not be whether to respond to an incoming signal. The question will be whether the signal was already sent 5,000 years ago by beings who are now expected back on the schedule they left us. The Sumerians believed the Anunnaki departed. Every version of the myth agrees on this. At some point, the great beings withdrew. The reasons vary. Some texts suggest conflict, some suggest completion of a task, some simply note the withdrawal without explanation. But the departure is consistent, and so is the expectation of return. In the cyclical cosmology of the ancient Near East, departure is never permanent. Everything comes back. The stars complete their cycles and return to their original positions. The seasons die and are reborn. The gods withdraw and then descend again. The cuneiform record is saturated with this cyclical logic, and the Anunnaki narrative participates in it fully. They left. The cycle continues. And at some point in the progression of astronomical time, at some configuration of stars and planets that corresponds to a moment in the great precessional wheel, the time of return arrives. Whether the beings described in the Sumerian texts were real, metaphorical, or something in between that our current categories cannot quite capture, the knowledge they left behind, or that the Sumerians preserved in their memory, is undeniably real. The astronomical data is real. The mathematical framework is real. The precessional cycles are real. And the question of what that framework was originally used to track and what it is pointing toward is a question that the tools of the 21st century are only now becoming capable of answering properly. So the next time someone passes over a Sumerian tablet in a museum display, a small, brown, seemingly unremarkable piece of baked clay inscribed with marks that look to untrained eyes like the footprints of small birds, remember what it actually contains. Inside that clay is the compressed knowledge of the first civilization. Inside its astronomical references is a body of data that contradicts what we think we know about how quickly human beings can accumulate certain kinds of knowledge. And inside its mythological framework is the record of a relationship between humanity and the sky that the Sumerians considered the most important fact about their world. They wrote it down, they baked it into clay, they built a civilization around the memory of it, and then they waited in the only way that ancient people could wait, by leaving a record precise enough that whoever came after them, however many thousands of years later, could read it and understand. We are the ones who came after, and we are only now beginning to read it properly. Whatever the tablets are pointing toward, whether it is a moment of cosmic alignment, a return we are not prepared for, or simply the mathematical echo of a civilization that understood the stars better than we have given them credit for, the signal, in some sense, has already been sent. It was sent 5,000 years ago, pressed into clay by hands that knew something we are only beginning to suspect. And it is arriving now as we decode it, character by character, tablet by tablet, cycle by cycle, moving toward a date that the mathematics of the ancient sky has always contained. The only question is whether we are ready to receive it. But readiness, of course, is not simply a technical problem. It is not solved by building better radio telescopes, or writing better detection protocols, or training more advanced artificial intelligence on larger archives of cuneiform text. Readiness is a question of perspective. It is a question of whether humanity is willing to hold two things simultaneously in mind: the rigorous skepticism that science demands, and the genuine openness to evidence that science also demands, without collapsing into either blind belief or reflexive dismissal. The Sumerian story challenges both extremes. For the true believers, the people who have already decided that the Anunnaki were extraterrestrials and that the tablets prove it, the challenge is to engage honestly with the scholarship that contradicts Sitchin's specific translations, to acknowledge that popular enthusiasm for a theory is not the same as evidence for it, and to understand that the real mystery in the Sumerian record is actually more interesting than the simplified version. For the strict skeptics, the people who dismiss the entire inquiry as pseudoscience and move on, the challenge is to engage honestly with the genuine anomalies in the Sumerian astronomical record, the precision of their Jupiter calculations, the apparent encoding of processional data thousands of years before Hipparchus, the internal mathematical consistency of their cosmic chronologies. These are not inventions of fringe researchers. They are features of the tablets that trained Assyriologists have noted and debated for decades. Dismissing the mythology does not make the mathematics disappear. There is a version of this story that is entirely mundane and entirely extraordinary at the same time. In that version, the Sumerians were simply brilliant, more brilliant than our cultural assumptions about ancient peoples typically allow. They inherited a long observational tradition from predecessors we do not know well, applied their remarkable mathematical intuition to that data, built a cosmological framework of genuine scientific depth, and then wrapped that framework in the mythological language of divine beings, because that was the language in which they thought and communicated. The Anunnaki, in this version, were not spaceship pilots. They were the personification of the astronomical order, the sky itself dressed in the form of persons, because the human mind has always made persons out of forces it cannot fully control. And the cycles in the cuneiform record were not a schedule of alien return visits. They were the Sumerians' profound way of saying that the cosmos is ordered, that history moves in patterns, and that the relationship between the sky and the earth is not random but structured by laws that can be read, if only you know how to look. That version is deeply satisfying intellectually, and it may be correct, but it leaves open a question that this version of the story cannot answer, which is the question of the origin of the baseline data. You still need to explain where the precessional numbers came from. You still need to explain how a civilization that had been in existence for a few centuries came to possess astronomical knowledge of that precision and depth. The answer, inherited from unknown predecessors, is reasonable, but it pushes the mystery back rather than resolving it. It says someone, at some point before Sumer, accumulated this knowledge, and that someone is unknown to us. Unknown, but not necessarily unknowable, because the Sumerians themselves tell us who it was. They say in tablet after tablet, in text after text, in myth and king list and astronomical record and divine hymn, they say that the knowledge came from the Anunnaki, from the great beings who descended from the sky. Whether you interpret that as metaphor or as memory, it is the answer the texts give. And the question of whether that answer corresponds to anything real in the physical world is the question that will define the next chapter of this inquiry. We live in a remarkable moment. The James Webb Space Telescope is identifying chemical signatures in the atmospheres of planets dozens of light years away. Biosignatures, indicators of chemistry that may or may not be consistent with life. SETI researchers are updating their detection protocols in anticipation of a signal that, for the first time in the history of the program, seems genuinely possible within the lifetimes of the people conducting the search. Artificial intelligence is processing hundreds of thousands of cuneiform tablets and will, within the coming years or decades, have read and cross-referenced more Sumerian text than any individual scholar could process in 100 lifetimes. And the scientific community has, for the first time, formally committed to a protocol in which the detection of an extraterrestrial signal is disclosed publicly, verified independently, and responded to only after broad global consultation. All of these things are happening simultaneously, and at the center of all of them, at the intersection of ancient record and modern capability, of astronomical mystery and archaeological discovery, of faith in human intelligence and humility before the unknown, sit the clay tablets, sitting in their museum cases, waiting to be properly read. The Sumerians pressed those marks into clay with the full intention of permanence. They fired the tablets in kilns so they would survive. They buried them, in some cases, in deliberate caches beneath temple foundations, as if they knew the civilization above those foundations might not last, but wanted the knowledge to outlast the civilization. They were, in a very real sense, sending a message forward in time. They did not know who would receive it. They did not know what language those people would speak or what instruments they would use to decode the wedge-shaped marks. They only knew that the knowledge was important enough to preserve, and that the cosmos was orderly enough that someone, eventually, would be capable of reading it. That someone is us. And what we are reading, piece by piece, translation by translation, tablet by tablet, is a record that is stranger and deeper and more unsettling than anything we were taught to expect from the first civilization. It is a record that sits at the boundary between history and mystery, between science and story, between what we know and what we suspect but cannot yet prove. It is a record that describes, in the language of astronomical cycles, an arc of time that bends toward our own moment. And it is a record that asks, with the quiet insistence of something that has been waiting a very long time to be heard, a single enormous question. Are you paying attention? Because the Sumerians, 5,000 years ago, were paying attention. They watched the sky for centuries. They tracked the planets with mathematical precision that astonishes us today. They encoded what they learned in the most durable medium they had and buried it where it would survive. They did all of this because they believed, with every instrument of their civilization, that the sky was not empty, that the cosmos was not silent, and that the relationship between the Earth and whatever lay beyond it was the most important relationship humanity would ever navigate. We are only beginning to find out whether they were right.